Hi, everyone. Thank you again for joining today's day 2 of our annual meeting and our session today. My name is Brittany Cunningham, and I am the project manager for the Body-Worn Camera PIP Training and Technical Assistance Program. As a reminder, points of view or opinions expressed herein do not necessarily represent the official position or policies of the U.S. Department of Justice. And now I would like to pass it over to our Body-Worn Camera TTA lead and director of the Camden County Regional Emergency Training Center, retired Chief Ollie Cuevas, to begin the session. Ollie.
Good afternoon. Welcome to our session. My name is Orlando Cuevas. As Brittany pointed out, I'm retired chief of Camden County Metro Police Department, but currently the director of the Regional Emergency Training Center. But been part of this project for a little more than 5 years. I got exposed to body cameras some years ago, and we worked with several agencies like CNA who helped us develop policy and best practices by working with several agencies throughout the country, other partner police agencies. So I'm a big fan of this project. Come to you as a user of this product, so I can vouch for it in separate ways. So thank you once again for joining our session. At this time, we'd like to introduce you to our panelists. Would ask John Morgan, Bryce Peterson, and Ian Adams if they would please introduce themselves, starting with John. Can give us, John, your background for the crowd?
Good afternoon, everyone. My name is Detective John Morgan. I'm with Bergen County Prosecutor's Office. A little bit about my background. I actually started off as an IT person. All 3 of my degrees are in computer science. I actually worked in corporate for 10 years before I decided to come over to law enforcement. So I kind of have a unique perspective in terms of 13 years working in intel counterterrorism and body-worn cameras and linking that technology up with my previous career experience. Looking forward to speaking to you guys today.
Thank you, John. And Bryce Peterson, please.
Yeah, hi, everyone. I'm a senior research scientist at CNA. I've done work on body cameras over the past almost 10 years now. I saw Doug work on the line, so I just want to give him a shout out. One of my first experiences with body cameras was leading the evaluation in Milwaukee, their body camera program, and then more recently worked with folks at CNA to do an evaluation of body cameras in a jail setting with the Loudoun County Detention Facility in Virginia.
Great. Thank you, Bryce. And Ian Adams, please.
Yeah, hi, everybody. Thank you for the invitation. My name is Ian Adams. I'm an assistant professor at the University of South Carolina in the Department of Criminology and Criminal Justice. I began my career in policing. I served over 12 years, became very interested in body-worn cameras, both as a user and eventually a scholar. So I've been involved in that world for about 10 or over 10 years now and continue to actively work in this space. So I appreciate you hosting me. Thank you.
Great. Thank you, panelists. So as the folks joining us today realize that body cameras are ever evolving and analytical tools are kind of popping up all over the place with different vendors, our expectations are growing and so are the public's expectations. So I want to take an opportunity to dive into some projects that are ongoing and some experiences that our panelists have, emerging analytical tools. So we'll start the conversation, if we could, by asking our panelists to discuss their exposure and their programs and projects that they've currently worked on or have worked on recently. Detective John Morgan from Bergen County Prosecutor's Office, would you please start our discussion?
Sure, absolutely. So one of the big projects that we're working on here is just the sheer amount of digital evidence management we're currently receiving. We had one critical incident, which you'll see in my slides, where we actually had almost 300 hours worth of body-worn camera video. And it gets to the point where, do you prioritize it by the officer on scene who was actually involved in the event, who was at the standoff? And the problem with that is you may miss something that's very relevant to the case at hand. That body-worn camera may have caught something being said. It may have caught a perspective that's critical to the case. It may have caught a flash in a window that nobody else saw, but that camera caught it. Unfortunately, to put a human in front of 300 hours of video, you'd be sitting there for most of the month, and eventually your bandwidth is exceeded. That's why we're really looking at machine learning as a tool to indicate areas where an event may have happened, things may have escalated, detect patterns or shapes or changes in the video that we may not have otherwise been able to detect. And of course, give the APs the ability to identify where their critical incidents are so they can zoom in on those key spots and then bring that information to their trial without having to review all 400 to 500 hours of video. That's really where we're going with the machine learning. It's come a long way in the last 5 years, but that's a very quick overview of kind of where we're headed with the machine learning.
I'm sorry. So as we have this discussion, I think it's important for the folks in the audience to know that the Bergen County Prosecutor's Office, coming from New Jersey, they're a little bit different than maybe perhaps some prosecutors and district attorneys' offices in that they run a collaborative project. They have a lot of street operations and things like that. So in many ways, in many regards, they function as a typical police department with several policing functions and equipping, in some cases, other police agencies. So thank you. Just bear that in mind as we have the discussion. Thank you. Next, Bryce Peterson, would you please give us a little bit of background on your project?
Yeah, so I'll talk today a little bit about something that we are planning to do and some thoughts that I have generally about how analytic-based tools using artificial intelligence can improve police accountability, transparency, and ideally officer performance. So I'll preface this and I'll say this again when I'm presenting officially, but I'm not an expert in artificial intelligence. That's not my area of research generally. But I do body camera research and have seen how these tools are now beginning to saturate the market, and want to talk more about how I think they can be used, some of the immediate applications I see, as well as where I think they're going in the future. So that's what I'll be talking about today.
Great, thank you. And Ian, would you please do the same?
Yeah, when Bryce and I were both invited on, Bryce and I have known each other's work for a decade now, I think, and we are carving very similar paths in terms of our outlook on this type of technology. So I'm currently involved in 2 RCTs looking at this type of technology in both sheriff and police contexts. Like Bryce, I don't particularly love the word AI or artificial intelligence. It kind of gets bandied about, but it is useful shorthand for sort of understanding a general thrust of using advanced analytics to try and solve some of the bigger body-worn camera specific challenges that have cropped up over the last 10 years as the police experience with these cameras has evolved. So looking forward to discussing that more in depth.
Great, thank you. At this time, we ask John Morgan, Detective John Morgan. I believe you have some slides that you'd like to work through.
Yes, sir. So quickly, I'm going to go over this. I can get very technical very quickly, so please ask questions. I'm always happy to discuss this offline as well. What we need to understand is machine learning has come a long way in the last 5 years. If you've had previous experience with machine learning or artificial intelligence, it's not like the stuff we have today. The ability to train the models and hone them in on what we're looking for is much easier with today's computing power. Also, you need to keep in mind, many of us are already using artificial intelligence, for example, redaction software and transcriptions. We're an Axon shop here in Bergen County, and I can tell you with the transcriptions, they're coming back 90% accuracy, sometimes higher. And that's huge for us because it frees up people that would have had to sit there otherwise and gone through there hour by hour to write it down by hand and then re-verify it. With the transcription, they can just make sure that the AI did it correctly and then include the parts where the AI did not catch the language. So again, we're already using these things in our day-to-day. We just have to consider how we can apply more tools to make our lives easier. And that's really the idea behind machine learning. It's not really to replace anything, it's to make our lives easier with the data management we're currently handling. So a little bit about Bergen County. We cover 246 square miles and have 1 million residents. There's more than 70 police agencies, and that's important for us here because all 70 of those agencies send their body-worn camera information to us. So we're in charge of any indictable crime. So all that body-worn camera eventually will be evaluated by us and taken to court through us. We also border New York City, Patterson, and Newark. And additionally, we have a regionalized SWAT team and a rapid deployment team. So that's additional 60 to 65 cameras we have just for SWAT, plus another 49 to 50 we have just for RDT. So currently our agency's got about 187 body-worn cameras in total just for us here. And we're currently expanding that. I believe we have another 50 on the way. So again, every municipality that has an indictable crime must share its body-worn camera footage with the prosecutor's office. And that's really formed an interesting dynamic in how do they get it to us? Because each hour is about 4 gigabytes of information. So what do we do in cases where we have 300 gigabytes of video footage, approximately 75 hours of body camera recording? So these are just some current stats I took off our system. We've only been up and running for about 1.5 years, and our external users really started taking off about 8 months ago. So internal usage alone, just our body-worn cameras, we're currently at 10.3 terabytes. And external for what the local PDs have sent us is 30.5 terabytes. So right now, we're currently partnered with New Jersey Innovation Institute. They're a component of NGIT on a grant dedicated to using artificial intelligence and machine learning to try and make our lives easier. So the key research questions we're trying to answer is, how can machine learning mitigate the burden of reviewing enormous amounts of body-worn camera footage? Can it put flags in there? Can it indicate where we need to go, what's important, where the escalation happened, or where did the de-escalation happen? Can we use it to identify escalating or de-escalating situation for training and compliance purposes? Can we use it as a supplemental tool for accountability? These are all questions that we're hoping to kind of answer as we go into this research project with the machine learning. So why are we even looking at machine learning? So we had a critical incident involving a barricaded subject. Response involved 30 law enforcement officers, and it was barricaded for 8 hours. That's 240 hours of footage from one incident. How do we know that one of those 30 cameras did not capture something relevant? Instead, they're going to prioritize it because the assistant prosecutors only have so many time. They're going to base it on whoever was engaged with the person and whoever had contact. However, some of those cameras may have still recorded something relevant that we may not see because we chose to rule them out due to just the length of time it takes to review them. So traditional versus machine learning. Traditional, we have to review the footage hour by hour. We have to assign somebody, detectives, APs, etc., to go through with it. Non-priority cameras may contain valuable evidence, like I already said. What about bandwidth overload? A human being is going to start to miss key items as soon as their bandwidth is exhausted. They're going to block it out. They're going to miss things in the audio. They're not going to see things that happen on the tape. I'm sure all of us have been there. We sit through a movie that's more than 3 hours. Eventually, it's like, yeah, we'll come back and finish it tomorrow. It's too much. It's too much to take in. Benefits of machine learning here. It can analyze the content for key indicators, prioritize critical videos. We'll be honest here, machine learning may not catch everything. I have yet to see a machine learning algorithm that's 100%. I've seen up to 98%, which is really good, but typically it's in the 90 to 95% range. Machine learning bandwidth, and this is an important thing to remember as to why we want to look at them, it's only limited to the capacity of the equipment. So unlike a human being that gets tired, the machine can continue to run the algorithm and go through those hours of tape, whereas we may not be able to. So a larger data set can better improve the fitness of a machine learning algorithm, but you have to be aware that as you increase the data set, you're more susceptible to having unwanted noise in the data. Additionally, algorithms must be continuously retrained. There's no one set solution for all instances and case. For example, you're not going to use one trained on search warrants for traffic stops. Two very different things. The machine sees them as two different things. You'd have to have a machine learning algorithm for each one. The reason we continuously retrain them is old data sets can introduce bias into machine learning algorithms. Social norms change, people change, the way we interact and with policing changes. So what may have been considered an aggressive act of somebody holding up multiple cell phones at one point in time is commonplace today. Everybody's got a cell phone, you're constantly being recorded. So it's important to remember most of all that AI, and mostly I think machine learning is really what law enforcement is going to use most of, are tools that can aid in the evaluation of large data sets. That's what all they are, is they're going to go through that really large data set. They're going to break it down into information that we can then turn into actionable data. Machine learning is not a complete solution, but it does make managing the data sets easier. And learning data has a huge impact on the fitness of the algorithm. So variations in policing, social norms, geocultural changes will influence the models. So a model that may work out in California may not work on the East Coast, down south may not work up north. And it's changes in society in general. So that's something you have to keep in mind. You can't just always take an off-the-shelf product and plug it into your region and think it's going to work. So the next steps for where we're taking this project, and we're always open to collaboration, is we are actually connecting our digital evidence management portal via API to a supercomputing capabilities at NGI. We're in the process of loading up 100 randomly selected BWC videos for a wide selection of different machine learning and possible situations. We're going to be testing and refining the algorithms until we get a high level of accuracy is detected. What we'll do then is we'll remove those 100 videos, randomly pick another 100 and run it again and see if that same fitness level or algorithm can then come back with similar results. And most importantly, and this is really where I think the benefit is with NGI, is we're trying to make it scalable. So not all of us have access to supercomputing capabilities, obviously, but the advances some companies have made, even NVIDIA with GPUs and the Ada Lovelace cores, make it possible to take these computing elements down to small servers, possibly even smaller than that, where you may actually be able to run machine learning algorithms on live streams of body-worn camera in the not so distant future. So that's kind of the direction we're heading in. I know that was a lot to take in, but I'm trying to stay on schedule for everybody. I'll be happy to make myself available afterwards.
Thanks, John. So before we go on, perhaps we can entertain a question or two. I'm sure there are folks in the audience have some questions at this point. Brittany, do we have anything popping up?
So I do see two questions specifically for John. First one is, can you talk a bit about the specific machine learning techniques you're using?
I can't talk too much about the specific ones because I signed a NDA with NJI, but the second part I can answer, is it possible for machine learning algorithms to study their own errors and improve their performance? The short answer to that is yes. You can actually they actually do it in the real world. It's kind of like genetic programming. You create almost 100 to 1,000 clones and you actually have them run competitive against each other. And then you take those better trained models and you use those to do next generation. So yes, it can be done, but I see that training can be quite tedious. It does take hours and hours to spend on the training model. So this is something where we're going to have it run continuously against data sets.
Thank you.
Those are all the questions right now, Ollie, that's come through.
Okay, thank you.
So yeah, I really appreciated hearing from John about the perspectives of an agency trying to do this in real time. I think we're about to enter the second big generation of body-worn camera technology, probably within the next year, primarily focused on not the sort of video machine learning algorithms that John is actively developing, but more on the verbal side, or the words that are being spoken. This is an easier computational task, so to speak. We already have the transcription, so the models are really about developing the ability to detect the kind of behaviors or outcomes that we're interested in detecting. As I mentioned before, Bryce Peterson is an eminent researcher in body cameras. We are traveling similar paths, and so we got together on the sidelines and decided to sort of break this presentation up. I got the easier version of this because Bryce is smarter than me. So I'm just going to sort of lay the groundwork for sort of the social forces and research background that have led us to this point. And then Bryce will kind of take forward from there. If I can take you back 10 years to 2012, when some of the first training units or body camera training units are really being spread around the United States. And then certainly as body cameras took off in late 2014 and early 2015, following federal funding, the goal of the technology wasn't, as John's working on it, the goals weren't to make policing evaluation of incidents better or faster or anything like that. There was a real clear social imperative around transparency and accountability, right? That's how the technology was originally developed and sold in the United States. This was an aspirational intent, the idea being that by putting cameras on officers, we would make their activities more transparent. Underpinning that idea is this idea of deterrence, right? That by putting a camera on somebody, we would deter unwanted misconduct. This is the area where I really became interested in body cameras, because I thought this was somewhat of a misdirection on what the technology was actually capable of. I was pretty cynical about the ability for the camera to capture the benefit, for example, of reducing use of force. But nonetheless, the cameras sort of came in on this wave of optimism that we could reduce use of force and reduce serious external complaints around policing. What's happened in the meantime? The primary work in this area comes from Dr. Cynthia Lum at George Mason. She did a 2019 review of about 70 studies, 70 empirical studies of body cameras between 2014 and 2019. And her team's evaluation, and one I agree with, is that frankly, those promised benefits failed to materially appear, especially in terms of use of force, right? The ability for body cameras to reduce force have so far been at best inconclusive, at worst failed to appear. The picture is a little different on the complaint side. Complaints, we do see some evidence that, when we look across all the dozens of studies, we see some evidence that perhaps body cameras can reduce these serious external complaints. However, we're really just observing that outcome, the complaint itself, not the mechanism for that outcome, which is, a fancy way of saying we don't know, is the camera having that effect through some change in officer behavior, or is it having some effect on complaints through an effect actually on the subjects that officers are dealing with, or on some other internal process between the two. And it's unclear still to this day about whether that's happening. So one might think that's sort of the end of the body camera research story, but it's not. And the reason is because of what John refers to here as the data problem, which is an understatement, if anything. We are generating petabytes of data in this country every single year. It's created the largest reservoir of policing data ever collected, and it basically sits there untouched completely. This has led some critics of policing to suspect that the reason we're not seeing use of force reductions is that there's hidden misconduct, right? The logic on that side says something like, well, there's probably a bunch of misconduct in that big data lake, and we're just not seeing it because police agencies aren't reviewing it, or no capable evaluator is evaluating that. A more nuanced take, and I think realistic take on it, is simply that the agencies are fiscally taxed, right? They are limited in their ability because it takes more than 1 hour generally to fully review 1 hour of body-worn camera footage, right? If you pause it at any time, if you rewind it at any time, you are automatically taking more time to review than it took to actually record that video. And when we're dealing with 800,000 officers in the United States, many of them with body-worn cameras, we're generating a ton of information, and it simply is not realistic to expect a human audit of all that footage. And so the status quo has basically been one of inaction. Agencies are not able to bring a human solution to this data problem, despite a desire to. And so you can see that desire in some of the policies that have popped up in agencies. A very common one is the so-called 10% rule. You'll see policies within agencies that require, for example, a sergeant to review some random selection of 10% of the videos generated by their squad. For the most part, these policy demands go unfulfilled. One, it's not clear that there's any randomization process possible to help the sergeants decide which cameras to look at or camera videos to look at. And second, there's no tracking mechanism to make sure that exactly 10% is being hit or even how that would happen. Frontline supervisors like sergeants are already time constrained. They already have a lot to do. Some of my work has shown, that the staffing crisis in the United States is reaching really, really severe levels post-2020. And so piling on yet another task on top of frontline supervisors simply hasn't been really successful. And it still leaves, frankly, 90% of, even if you're hitting 10%, you're leaving 90% on the table. And so this has given way to event-based review, which is the primary way that body cameras get reviewed in the case of some sort of critical incident, like John was talking about a SWAT event involving 240 hours. Generally, that's actually how we see the primary use of auditing in the body-worn camera function or body-worn camera context. But it doesn't solve the financially taxing, it lacks systemic or randomized methodology, and it lacks any kind of tracking. So this gives way to a couple of problems that will set up Bryce to talk about potential solutions going forward. We have a huge corpus of unaudited data. In fact, the CEO of Axon in 2018, in his Q3 financial report, announced that Axon was the holder of the world's largest database on policing. And what was he talking about? He's talking about this footage, right? This represents both an opportunity for policing, for researchers, but also for the market itself to capitalize on. So we're beginning to see a great number of entrepreneurs come into this space with new ideas about how we can solve this problem. We've also lost some focus on the one hope from the policing side for body-worn cameras was that we could capture promising or positive interactions with policing and use that to better, one, rehabilitate some of the policing image, and two, use it as training material to hopefully gain better outcomes for other officers. But if we're not reviewing that footage, we'll never find those positive interactions. And finally, I think at the end of it, the last 10 years of body-worn camera footage has shown us that perhaps focusing on use of force as an outcome, as either the primary or sole outcome that people are interested in, can mislead us a bit about the promise of technology. Because I may have sounded cynical about what's 10 years of research in body cameras has given us. What it has discovered along the way is that there are a lot of promising benefits. They just weren't the ones we expected. And so as we sit here today, 10 years into this big experiment, about to hit, I think, the next phase, the next important phase in body worn camera technology, those are some of the problems that I'm thinking about a lot every day. Thank you.
Thank you very much. Bryce?
Yeah, so it's almost like Ian and I planned that, which we did. If you already said that, but I wanted to build off of what Ian talked about, but also some of what John talked about. So they kind of set up the problem. John talked about what they're doing in their jurisdiction, and Ian kind of talked about the problem that we're having, that we're seeing on a national level with this, again, petabytes of data that's just sitting there completely untapped until eventually it's erased from the system. And so what can we do about that? How can we use that data? How can we harness, again, AI? And I'll talk about specifically what I mean when I'm talking about artificial intelligence and the branches of it that I think are most promising for this kinds of technology. What can we do with AI? What can we do with body camera footage to meet those goals of transparency, accountability, and officer performance? Okay, so AI-based tools, I don't know what the right terminology is. I'm just using that term here because it kind of captures what I'm talking about. But an AI-based tool is something, and I'll give some examples later on of tools that are already on the market or will be soon, just to give you a flavor of what's out there. But these tools are things that automatically process vast amounts of body camera footage in a systematic, objective way, right? So and John talked about it with their machine learning algorithms that they're creating. It's a way for all body camera footage within an agency to just be processed through and to derive key information from that footage. Now, how it does that, I'll explain in a little bit with some of the computational science techniques that are out there and how those are being applied to body cameras. But that's their overall goal, right? Systematic review of all recorded interactions. It's a cost-efficient alternative to individual review, as Ian just highlighted, something that all agencies are facing. So what can these tools do? And I'll talk more about each one of these later on in the presentation, but they can automate that supervisor review process, right? So the auditing or the 10% rule that Ian mentioned, I think one of the concerns is that the selection of 10% of body camera footage is never random. Whenever supervisors are actually able to do that, how are they randomly selecting footage? Which officers are they using? These tools can facilitate that. They can automatically pull X hours of footage and populate it on a supervisor's desk for them to review. It can facilitate keyword searching across all body camera footage, and they can also produce summary metrics of language and behavior, again, for all officers who are having body camera footage. And that facilitates and allows supervisors, so sergeants, lieutenants, whatever, to respond to appropriately officer behaviors and language. So to set up this conversation, let me talk about the two branches of AI that I think are most relevant for body camera footage review. So Ian mentioned this already, natural language processing is one, and computer vision is the other. And they're kind of at different stages in development right now. So natural language processing, or NLP, essentially what it does is takes speech in its natural form. So, us talking to each other, and it extracts key features from that, right? So there's linguistic features and paralinguistic features. Linguistic features are simply the content of your words, what words you're using, how many words you're using, etc. And then paralinguistic features are pitch, loudness, tone, intensity, other kinds of parts of your speech that we all hear when we talk to each other. They're trying to train kind of this machine learning, AI, NLP-based techniques to extract that automatically from body camera footage. So in some very simple uses and applications, I think Elliot in the chat had mentioned this. So speech to text conversion is a pretty well-established field at this point using NLP language. So it just takes our speech, it identifies what words you're using, and it puts it down into a transcript. That allows you to automatically summate text, do keyword searching, those kinds of things. Some more complex uses are to assess underlying emotions, thoughts, concepts, and the kind of social context of your speech. That's a feature of NLP that is improving, but I would say it's not as well advanced as simple kind of speech to text conversion as what we're seeing right now. So I just want to give you an idea of from what I understand, at least, how these tools are actually working. This is just a high level kind of example of how these tools take body camera footage and translate them into useful metrics, right? So body camera footage is uploaded to a server, either cloud-based or in-person server. Some way that AI-based tool is integrated into the server, and then it does its job, right? So it transcribes all of the body camera footage, gives you text of everything that's being said, and then the NLP tool itself extracts key features from those transcripts. So here are some examples of positive or negative linguistic features. So how often officers are using formal language, explanations, politeness, gratitude, or on the negative side, if they're using insults, threats, profanity, directed profanity, it can identify and summarize this information. That's how NLP works, these tools. And this is just, again, a general overview of how these tools work. They take body camera footage, they translate it into usable metrics, and that facilitates something on the front end for users. So whether it's a dashboard, metrics that are automatically summarized, reports, searchable databases, something on the user end that allows them to take this information and do something with it, ideally improve accountability, transparency, those kinds of things. Computer vision is a much less developed field, at least as it applies to body cameras. So the same way we're talking about NLP for audio and for speech, computer vision works on images and video, right? So in some of its simple forms, it can identify images, it can track objects, it can do perimeter detection, facial recognition, and kind of content-based image retrieval. Those are some of the terms that are used in the computer vision field. How it applies to body camera footage, some kind of simple and straightforward applications are facilitating automatic redaction. So when footage needs to be released to the public, rather than an individual going through and identifying faces, license plates, things that need to be blurred out in the footage before it's publicly released, that can be done in an automatic way using computer vision-based applications. Weapons identification or kind of other tagging features that need to happen in body camera footage, it can automatically say whether there's a weapon or something else in the footage. In the future, I would say this is not ready for prime time right now, but in the future, I think the goal is for them to be able to do even more advanced things. Like, so for example, from facial features, when we look at someone's face, we could tell generally whether they're angry, upset, or sad or whatever. That is something that's being developed right now with artificial intelligence. I would say it's not, to my knowledge, that is not well developed in any tools that are publicly available, but that is something that's being worked on to be able to identify other features in video that can detect things like aggression, violence, just from the video footage. So I'm going to just cover this slide very quickly. So these tools have been used already. There's lots of, John just talked about how they're using similar applications in their own department. Researchers have used AI, and mostly when I'm saying they've used AI, they've mostly used natural language processing at this point to process body camera footage, and they've shown that it can be used to identify when officers give introductions, offer explanations, use de-escalation techniques, following departmental policy, using certain words when they're interacting with community members. Those are ways that it's been either proven or validated, or at least is promising in its uses. Some of the immediate applications from these kinds of technologies, as I mentioned previously, is to facilitate automatic auditing, redacting, tagging in videos. And an area where I think we are soon to see a growth, there's already some tools on the market right now, which I'll show on the next few slides. But I think the next step of this is to facilitate that kind of officer performance accountability metrics that Ian kind of set me up for. So on the next 3 slides, can we go to the next slide, please? I'm going to show you some screen. This next slide is going to show you kind of what that process looks like. And then the next slides after that will show you screenshots from tools that are on the market right now. So the way I think this would work, you get body camera footage, it produces some kind of metrics and officer behavior based on the processed body camera footage. Supervisors see that information and then they respond to it accordingly, right? So if they see professional behavior, maybe they engage in some sort of positive reinforcement, commendations. If they see unprofessional behavior or language, then they take corrective actions as needed. And this is a more proactive and objective approach than, again, that sort of 10% rule, or in an ad hoc way, taking body camera footage, reviewing it here and there. This allows supervisors to respond to all body camera footage in a systematic way. So this is a tool that's currently available through Axon. It facilitates keyword searching, and I'm not advocating for any of these vendors, just to be very clear. These are just the ones that I've seen that are available or soon to be available right now, and just to give you a sense of what they look like on the back end for users. So this is a screenshot from Axon, facilitates keyword searching from all the body camera transcripts. This is a similar tool from a company called Trulio, which takes it a step further and produces regular metrics on officer behavior around professionalism and risk. And you can see there at the bottom of the screen, it gets metrics related to explanation, politeness, threats, directed profanity, things that I mentioned previously. And you can do this for individual officers, groups of officers for a certain period of time, which again allows supervisors to respond in more real time to behaviors and types of misconduct or problematic behaviors that aren't just uses of force, right? This allows you to respond to, again, other types of professional or unprofessional behavior, positive and negative. And then this is another tool from a company called Polis Solutions. To my knowledge, this is not yet on the market, but this is a mock-up of what they expect their tool to look like. And it's similar to Trulio. It captures some information from body camera footage. I'm just going to end with a few thoughts and considerations. So what do you do with this information? I think this is a way for, if we're again thinking about accountability and transparency, departments can think about releasing this information either for their department as a whole, specific districts in their agency in a regular basis to show whether these behaviors are and performance metrics are changing over time. There's of course been pushback that I think the field is still considering, especially from police unions. They're worried about officers using this technology to go on fishing expeditions. Supervisors going on fishing expeditions for their officers, singling and targeting specific officers. So that's a challenge that we'll need to overcome. There's technological limitations. John talked about these a little bit, but with my presentation specifically with computer vision, it's really not there yet. It is being developed right now. And then there's some research limitations. We're still not sure how best to use these tools. There's limited validation studies, so we don't know in every case that they're doing what they say they're doing. And that's something we need to figure out. Okay, thank you.
Great, thank you. So at this time, we'd like to open up the floor to any questions. Brittany, do we have anything in the chat?
So one of the questions that we do have, Ollie, and this is for all of you, a number of agencies do not have the resources to be able to, utilize such things such as AI, so the natural language processing or machine learning. Can you talk a little bit about what you would recommend to those agencies, or how you have seen agencies utilize it when they may not have resources ready available to?
One of the best partners you can get is local academia. Academia can really be your support net if you don't have the resources available to your department. And also keep in mind machine learning and AI in general, like Bryce was talking about, computer vision. They're cutting of edge. 5 years ago, I would have said your machine learning algorithms probably would have been the 40–50% area. They've really come a long way, but they're not 100% there yet. The problem we're running into is technologies advancing at the same time, scalability is coming down. So one of the conversations I had with NJII is, would it be possible to put some of these machine learning algorithms on something as small as a Samsung phone? The short answer is yes, if it's one of the more modern ones, but we have a lot of work to do to scale it down to that size to make it more affordable to the smaller departments.
Yeah, and I would just add to John that, I don't think the future looks like, frankly, every agency developing this type of internal capacity. It's very likely that we'll see some sort of oligopoly, like that we have now, where you have 2 or 3 major purveyors of this technology. We can anticipate, using historical trends, that these things will get approximately twice as good every 18 months or so. That's based off of a very famous Moore's law, which has to do with hardware. If anything, the software rate is even higher right now in terms of what we're seeing in this space. So it's very, very likely that this will become another vendor for agencies, and that the cost, I anticipate, not being that high, certainly probably less than the initial spends that we were seeing on body camera hardware itself. So overall, I see this as an efficiency gain over time. The kind of projects that Bryce and I are interested in right now are quite expensive, as an initial efficacy test of these types of solutions, but that won't stick around for long. And I would say using NJII and BJA type of grants is another option for agencies that want to get in on this early. Working with academics and other researchers like CNA is a great option.
Bryce, any thoughts on the same subject?
Yeah, I would just echo what Ian said. I think, in every other field where you see this proliferation of technology, you start to see the cost go down. You start to see vendors integrating technology together. So for example, if you're an Axon user, Axon already has a technology or a tool that's available through them. I expect that trend to continue with other vendors as well, where they'll start to package these deals together. So that helps the cost go down. And I think Ian said this already, but it's hard to underestimate the potential cost savings of something like this, right? So if these tools are ever proven to be as good or can save supervisor time in a substantial way, so they're not reviewing 10% of all body camera footage, even though we know that's not always happening anyway, but that could be an actual cost savings to an agency, that improvement in efficiency. So I would expect those things to help drive the cost down, similar to what we're seeing with body cameras.
Okay. If I take just a quick second and ask folks to expand upon Brittany's question, if possible, is there anything that you would say for the audience? Because we do have a lot of agencies that are of smaller size enrolled in the PIP program. Is there any tip that you see currently in use? I know I've seen some agencies use like, translation software or one that's built within their software, their body camera software, and then they look for keyword searches. Is there any tips that you have for the group that could be easy to employ for those, those smaller agencies with less funding? I guess if we could start with John.
For smaller agencies, utilize whatever you can on the open source community. The only problem from the open source community, that's the software that is available free of charge. There's some really good artificial intelligence algorithms out there that you can play with. You just have to verify it because it may not be accepted in court. So while it may speed up the process, somebody's still going to have to take the time, even if you do use that free tool, to go through and manually verify it. Really, it's all about just trying to automate that digital discovery unit or that process so that you can do the redaction, the transcription, and verify the video as quickly as possible without having to allocate 4 or 5 detectives like I've seen with some of my local departments where they actually had to allocate 3 detectives from their main squad just so they could do the redaction.
Thank you. And great advice about the prosecutor and district attorney involvement. Any others?
I'm afraid I don't have great advice here because I think it's a matter of scale. Small agencies have a smaller absolute problem here, but it's the same relative problem that large agencies do, because the problem is really driven by the numbers of officers you have generating body-worn camera footage, right? And so it's a more from a relative perspective, I think all agencies are under essentially the same pressure. There might be some variability depending on their call volume and the number of, but really it's going to come down to a numbers game. How many cameras do you have going at any given time? And on average, how many videos are you generating? But I think it does tie into something that John Markovich here is pointing to, and that's Chalar, Pisa, and Sistema's recent publication, which I when I saw it, thought was the finest example of qualitatively undertaking this type of process that we're talking about in human form, right? And I've talked with Eric about this study and given him that credit and asked him what he thought about the capacity for this sort of process that they used to be expanded. And he was, not a fan of that idea, nor am I. It's just so time intensive. What they're doing there, what is breaking every camera down, every camera video into 5-second intervals, and then coding each 5-second interval for any behaviors by either suspect, witnesses, or officers for everybody on scene. It's just incredibly time intensive. So it's very good. You can get a lot of rich detail out of every body camera video, but it really shows the limitations of the human approach to this type of problem. We're going to have to get beyond that. I think Bryce covered it well. We're going to begin with natural language programming that we all use every time we say, hey, Siri or hey, Google. And we're going to eventually get into the vision models that are frankly cutting edge right now, but we can see the horizon on. So I think we'll come back we'll in 5 years and we'll be in a very different place.
Thank you. And Elliot, you pointed out in the chat that these tools are evolving and vendors have new products. So we want to encourage everyone to look at them broad, wide. We know the field's exploding, as Ian pointed out so correctly. So I want to thank everyone. I want to thank the panelists for their time. Brittany, send it back over to you.
Well, thank you, Ollie, and thank you everyone for joining today, as well as John and Ian and Bryce. Thank you for your time.